All right, here we are at Lab 2.4, dehydrating a hydrate. So we are using copper chloride again, right? Your instructions tell you, first off, to weigh a dry beaker and then add some of our green stuff. Again, you can see mine in there. Mine's a little more crystalline than yours is. Yours should be more powdery, but I'm reusing this from another procedure and it's kind of stuck in there, but it'll be fine. Anyways, you'll notice its color, right? You'll get a good weight off of the scale for it and write that down in your lab procedure because you're gonna need it, right? So our question for this is, we know that our copper chloride is what we call hygroscopic. So that means that our copper chloride likes to hold on to water. The way that these crystals form, kind of form a prison or a gel cell. And if they're around any kind of humidity, it's gonna steal some of that water and lock it inside its crystal structure. We wanna know exactly how much water a set amount of copper chloride is going to react with, or kind of, well, it's not a reaction. It's unfair to say it's a reaction because this is merely a physical change. There's not any chemical bonds that we're forming and breaking. They're literally just physical attraction. Because water we know is polar, and we're dealing with an ionic substance here, so that attraction there is momentary, but it is because of the polarity of the water. But anyways, we want to know, for every 1 mole of copper chloride, how many moles of water are there in this hydrated substance? And we're going to kind of do that reverse-wise. So I've got it hydrated here. We know it's hydrated because it's blue, right? So we're going to heat this up. So we're going to weigh our copper chloride in the beaker beforehand. And then we're going to gently heat it. So we've used this Bunsen burner before, right? If you have tongs, you can use tongs if you're scared of the water, or an oven mitt. We're gonna gently heat it, right? We don't want to ram the beaker onto the flame because that might crack our beaker, and that's not what we want to happen. We also don't want to risk heating up our glass and burning ourselves. So we're just gonna gently heat this up. And we should see as we gently heat it up, let's kind of look at it closer. You're gonna see. So we kind of heat our water up. I'm gonna see, hopefully, some steam kind of come off here. Oh yeah, you can kind of see it. I'll show you in a minute. You see the steam, kind of the condensation kind of forming on the side of my beaker? I can hear it kind of sizzle too. So we are giving our water particles enough energy that they can overcome that attractive force with our hydrated substance, right? So we're giving them enough energy that they can actually now fly away and be free of this hygroscopic substance. Okay, so I've been heating this up for about 3 minutes. I don't expect yours to take that long, and you can kind of see I'm starting to get a color change down here. So mine is kind of looking burnt at the bottom. We can definitely see that there's like a bronze color coming. Yours I would expect to look white since you have a powder form, and this one might have some impurities in it because I did use it over from a leftover lab. But anyway, so yours, you can definitely see how the structure's changing too. That powder, that crystalline structure is kind of breaking down, and we're left with a little more of a powdered form, which you'll see too with yours. I think your procedure tells you to do this a couple of times and weigh it continuously until your weight doesn't change, and that's how you know you're done. And we should see our weight getting lighter, even though we're not doing any chemistry. So why is our weight getting lighter? What are we doing in this reaction? We are taking our hydrated copper chloride with some water in it, and we are making that water evaporate. So we are turning this hydrated thing into just copper chloride. Right? So we're going to get the weight of our hydrated copper chloride with the water and our weight of just the copper chloride. With both of those numbers, we should be able to easily do some basic math and figure out how much water was in our amount of copper chloride. If we can figure out how many moles of copper chloride we had at the end, we know our weight of water. we can calculate how many moles of water we had at the beginning and our moles of copper chloride, because the amount of copper chloride didn't change. We can compare these two numbers of moles and figure out exactly how many moles of water we had for every 1 mole of copper chloride. If you can follow through this procedure and do that, you have calculated an empirical formula. And this will be a good anchor for you as we look at how we calculate the empirical formula of actual substances from mass data, which is the major part of the math that is in Module 8, more stoichiometry. So hopefully that helped. Let me know if you have any questions. A couple of safety features for this lab. You are working with an open flame, right? So be careful. If your beaker were to crack during the course of this, it's okay. Just chunk it in the trash once it's cooled down. Be sure not to grab the glass. You might want to sweep it up. Don't grab it with your bare hands because it might cut you. And keep your hair away from the open flame. So use it with common sense. You might want to have your parents work with you just to kind of keep you safe. But anyways, this lab is not that hard. And like I said, yours might look burnt and crispy like mine, or it might look white and powdery. Either way, your reaction has been working if you see either of those changes. So good luck. Let me know if you have any questions.